Now, in this lecture, we trace the curve y square times of 2a minus x, which is equal to x cube. We have to trace the curve y square into 2a minus x, which is equal to x cube. Let us try to open the bracket y square into 2ay square and xy square 2ay square minus xy square, which is equal to x cube. So this is the equation. This is the equation of curve which we have to trace. We check the following points to trace this curve. The first point is symmetry. Here, since the power of y is even, just look here, here the power of y is even in each and every term. In this term, y is absent. Therefore, the given curve is symmetric about x-axis. Now, we know that there are 6 types of symmetry. So, if we check it, is it symmetry about y-axis? No. Why? Because the power of x is not even. And since the power of x is not even, so it is not also symmetric about both the axes. Also, if we replace x by minus x, y by minus y, then the equation of curve will change. So it is also not symmetric about opposite quadrant. If we replace y by x and x by y, then also the equation of curve will change. So this is also not the symmetric about line y equal to x, and same thing for the line y equal to minus x. Hence, this curve is only symmetric about x-axis. Now, let us try to check the another point. What is another point? Origin. Since there is no any absolute constant terms present in the curve, so the curve passes through origin, right? And now how to get tangent at origin? So we know that the tangent at origin is given by what is the lowest degree term of the equation should be equal to 0. So if we see what is the lowest degree term, it is 2a y square, which is the lowest degree term. So we have to equate it equal to 0. Now, since 2a will not be equal to 0 because it is absolute constant, so y square is equal to 0, and it gives us y equal to 0 and y equal to 0. So now we can say that there are two tangent at origin, y equal to 0 and y equal to 0, and both are coincide to each other. So we can write down y equal to 0. Now what is the nature of the origin? Since there is only one common tangent at origin, therefore origin is cusp. Means like this, the origin will be like this. Suppose we are saying that y equal to 0 means this is y equal to 0. So there should be this is cusp. If you are saying this is like this type of cusp we will get. So this is the common tangent for the both the branches of the curve. So this is the common tangent. Okay, let us go ahead. Intersection with coordinate axis. From 1 we have 2a y square minus xy square equal to x cube. So if you put y equal to 0, if you put y equal to 0 here, we can get x equal to 0. If we put x equal to 0 in this equation, so x is 0, x is 0, so we are also again getting y equal to 0. So it means that curve meets coordinate axis only at origin, that is 0, 0. Now the next thing is the asymptotes. What is the meaning of asymptotes? Asymptotes is a straight line which is finite distance from the given curve but intersect at infinity. Now, So there are three types of asymptotes. First is called asymptotes parallel to x-axis. So here, what is the highest degree term of x? It is x cube. Highest degree term is what? It is x cube. And asymptotes parallel to x can be obtained by equating the coefficient of highest degree term equal to 0. So what is the highest degree term is x cube, and what is the coefficient of x cube? It is nothing but 1. So 1 cannot be equal to 0. It means that there is no any asymptotes parallel to x-axis. Let us take for the asymptotes parallel to y-axis. Here, highest power of y is y square. Just look here, the y square, y square. So, and whose coefficient is 2a minus x. Hence, asymptotes parallel to y-axis is given by 2a minus x equal to 0, which gives us x equal to 2a. So, x equal to 2a is the asymptotes which is parallel to y-axis. Means now we have, this is the axis, this is x-axis, this is y-axis, and there is a asymptotes. This is what? It is x equal to 0, and this is x equal to 2a. Right, so this is what? It is the asymptotes parallel to y-axis. And now we have already seen that at origin, there is a origin is nothing but a cusp. Origin is nothing but cusp. So like this, and this is asymptote. So it means this curve will not intersect this asymptote. So it may be go up to infinite, but will not touches the curve or this asymptotes, because it is the definition of asymptotes. And since there is a one parallel asymptotes parallel to y-axis, so there is no any oblique asymptotes over here. Let us take the fourth point, which is reason of absence. From equation number 1, we have y square into 2a minus x, which is equal to x cube. So if we write down y square, what is its value? It is x cube upon 2a minus x, x cube upon 2a minus x. And if we find what is the value of y, so it is nothing but x root x divided by root over 2a minus x. Now, if x is negative, if x is negative, the negative of any number whose root of any negative number is imaginary, then y will be imaginary, right? So there is no part of the curve for which x is negative, that is left hand side of y-axis, right? We know that where is x-axis? X-axis is negative. So now this is the y-axis, this is the x-axis. So this part is negative x-axis. So there is no part of the curve for which x is negative. Second thing, if 2a minus x, this 2a minus x is again less than 0, what it means? It means 2a is less than x or x is greater than 2a, then y will be also imaginary. What will happen? If this 2a minus x, if this 2a minus x will be negative, then root of negative number is again imaginary. So it means that there is no part of the curve right hand side of the line x is equal to 2a. So let me try to draw the curve. First thing, this is x-axis, this is x-axis, this is y-axis, and now we have already seen that the curve passes through origin. So now the curve passes, this is the origin of the curve. The next thing is, if what is the tangent at origin? So tangent at origin is nothing but y equal to 0 or x-axis itself. And we have already seen that since there are two tangent at origin, but both the tangent are coincide to each other. So we have already seen that the origin is cusp. And now, since it is cusp, so we have to draw the curve like this. And also we know that this curve is symmetric about x-axis. So we are getting the same type of curve above the x-axis and below the x-axis. Again, we know that we have already checked that this x is equal to 2a is the asymptotes parallel to y-axis, right? So the curve will never cross this line x is equal to 2a, right? So curve will lying between, and again we have already seen that if the value of x is negative, then the y will be imaginary. If the value of x is greater than 2a, then also here greater than 2a, then y will be imaginary. So it means that there is no part of the curve which lies left hand side of the y-axis and right hand side of the asymptotes x equal to 2a. So this is the approximate shape of the given curve. Thank you.